C what?
104. That's what I'm at.
Who's 207? Me too. Where? There probably is a good teacher in there. Me, some good teacher, and a couple of others. When does first hour start tomorrow?
Just direct that at camera.
9:59.
What time do
Okay.
you get to leave here in the morning?
For those of you that do not test tomorrow, it is probably the day of the year where more people are late to first hour class than any other day. So even though your class starts later, get there earlier, get there by 7 or by 9:45, 9:50. Okay? Don't be late. All right, let's rock. No,
All
not
night.
rolling. Just rock. Homework, go.
I didn't have time.
I'm almost done.
I did 3 problems. That's what I started.
I got bored in the car and I was like, I have no homework. And then I got home and I didn't finish and I was like, that's enough for today.
Like that is just
What I did was, I had to clean when I got home, so I cleaned the whole bathroom. Bath included. It was terrible.
I got the whole house was a mess. It was reorganized.
And then I had to write a sonnet.
I don't like 67.
I only wrote one stanza. I have to check the right.
What number is that?
67.
Oh, yeah.
Hello? Good afternoon, everyone. I have 35 minutes. May I have those 35 minutes? Thank you. 1 plus tangent of theta squared. Go. 1 plus
2 tangent theta
2 tan theta
plus tangent squared of theta.
tangent squared of theta. Square double square. Anything you like now?
Yes.
What?
1 plus tan squared theta.
1 plus tan squared of theta is secant of theta?
Squared.
Squared, yeah, everything's squared in the Pythagorean identities. So secant squared of theta plus 2 tangent of theta.
And then
I
put it
believe that
in
they
terms
asked
of sine and cosine.
for everything in sine and cosine.
Yeah.
So we need to put stuff into sine and cosine.
1
So what are we writing?
over cosine squared of theta
1 over cosine squared of theta
plus
plus
2
2
sine squared of theta.
sine of theta over
Oh, yeah,
cosine of theta. I would get a common denominator now. I don't like 2 fractions. It's not simple enough. Cosine squared of theta, I would agree. So cosine squared of theta plus cosine squared of theta. First numerator is 1, nothing happens to that fraction. Second numerator is
2 sine of theta cosine of theta.
sine of theta
Cosine.
cosine of theta, because we multiplied the bottom by cosine of theta. We now have common denominator. So let's write it as one big fraction. So 1 plus 2 sine of theta cosine of theta over cosine squared of theta, which I believe is probably the answer. Is that correct? It's in the back of the book?
Do the
It needs to be the one. Yeah, which to me, this is why I don't like this problem, because they ask us to simplify it. It doesn't look very simple. That's exactly what I was going to say. I mean, that looks more simple than that does. So, perform the indicated operations and simplify your answers if possible. Leave all answers in terms of sine of theta and cosine of theta. It is. Yeah, no, I'm not a big fan of that one. But, oh well. Any others? phrase here. That's what I was just doing. All right, and let's move on. Somebody asked me.
I asked. Okay.
She's first, you're fourth. All right, just kidding, I'm all four. Top five. Okay. Today is basically more of the same. But we'll switch a few things up a little bit, just because we can. What's different?
It's negative x.
The fact that it's x instead of theta. How does the tangent of x differ from the tangent of theta? You know what? The answer is not what you're expecting. The answer is?
It doesn't.
It doesn't. It makes no difference. It makes no difference whether it's the tangent of x or the tangent of theta or the tangent of alpha or the tangent of n, the tangent of, I don't know, anything, Joe, the tangent of Joe. It makes no difference. It does not matter. As long as we have the same stuff. You know, and we won't have a tangent of theta followed by a tangent of a. That just won't happen. So don't worry about what we're getting the tangent of. Okay? That's number one. Number two, what else is different? The negatives. That we do have to pay attention to. Okay? Tangent of negative x times the cosine of negative x. Kind of rings a bell a little bit. Tangent of negative x. Do you remember ever getting the tangent of negative x or negative theta or anything like that? It had, yeah.
Backwards.
It had to do with, how about this? How about if I phrase it this way? What if I told you that sine and tangent were blank functions and cosine is blank function? Right? Right. We're talking about odd and even functions here. Okay? And they, when we start looking at the negatives, the negative x's or the negative thetas or something like that, that's what we're going to talk about to hopefully make it easier for us. Now, do we remember what types of functions each one was? Sine was an odd function, I agree. Cosine was an even function, I agree. Tangent was an odd function. So sine and tangent are odd functions, as are
Cotangent.
their
Other functions.
reciprocals. So sine and tangent are odd, cosecant and cotangent are odd. Cosine, secant
Are even.
are even. Cool. What does that mean? I know. That's why I asked. An odd function means that the tangent of negative x is equal to negative tangent of x. In other words, if the tangent of x is 1/2, the tangent of negative x is negative 1/2. If a function is even, cosine of negative x is equal to the cosine of x. Meaning that if the cosine of x is 1/2, the cosine of negative x is still 1/2. Even function, whether we have a positive or a negative that we're putting into the function, we still get the same answer. Does that make sense? Okay, let's use that here. Let's use the odd-even function thing here. So what can we write? Negative tangent of x times cosine of x. So we took tan of negative x and turned it into negative tan of x. And we took cosine of negative x, because it's even, and just said that's exactly the same as cosine of x. Does that make sense? So that's where knowing the odd-even function thing makes a difference. Done? No, we're not done. What's next? Sine and cosine, sounds good. Tell me what's right. Negative sine of x over cosine of x times cosine of x. Any good news? Can we cancel here?
No. Yes.
Why can we?
It's multiplying.
Because it's multiplying. It's multiplying, and if we're multiplying, anything from the top can take anything from the bottom. So cosine take out cosine gives us negative sine of x, which is our answer. Now I like that answer because it's simple. I like simple. I like simple.
Ouch.
Questions there? Okay, here's the next one. When you look at that, there are a few different thoughts that you might have to start. And distribute is certainly right up there at the front because that's what we've done for years, right? You know, if we see something like that, our instant thought is, let's distribute. Are there any other possible thoughts out there?
No, look at the equation.
We could change things to sine and cosine. That also works fine. Are there any other possible thoughts out
Pythagorean
there?
identities.
The identities. Tangent squared of x plus 1. Oh,
Secant.
that's an identity itself, isn't it?
Uh-huh.
That might be the easiest way to go. You know? If we know what tangent squared of x plus 1 is, what is it?
Secant.
So we can just say, uh-oh, you're leaving? No, we can only have 2 per class.
Now we can change the sine and cosine.
Hey, that's kind
Did I ever tell you that when I was teaching regular algebra classes, I would give them bathroom passes? They'd have 4 per semester.
Oh yeah.
Semester.
Per quarter.
I don't want you to leave class. How many people, let me ask this. In this class, how many people, from the number of times that you have left class to go to the bathroom, how many people in here would have had no problem with 4 bathroom passes for a semester? Right? See?
I drink a lot.
Yeah.
No, but the reality is, there's really no, most people, not so much from here, which is why I don't do it in here. But in the other classes, most people leave not to go to the bathroom. They leave to
Do other things.
go find their friends and hang out with their friends. Roam the halls, do stuff like that. I, as a teacher, surprisingly, am not a big fan of that.
Surprisingly.
I know, isn't that shocking? I want you to be here. So, therefore, if you have to go to the bathroom, you have to go to the bathroom. But, well, and in here, most people don't want to miss because, and I like that. That's good to me. But in those other classes, they just want to go. Yeah, I just want to leave. I don't care what it does to my grade or if I miss stuff. I don't care. Anyway, I'm sorry. I gotta keep going. What do we do now?
Sine and cosine.
Sine and cosine. So talk to me.
Cosine squared x.
Cosine squared of x times
1 over cosine.
1 over
Cosine squared.
cosine. Huh.
Wait,
Equals
what did
one.
they cancel out at the beginning just because cosines are
It equals 1.
Show the steps. So what happens here?
It equals 1.
They cancel, which gives us.
1.
I love those.
I feel like there's always something leading up to this. When he's like, I love simple problems. They're so great and amazing. And then we get this problem that takes up the entire whiteboard.
You know, I didn't say I like simple problems. I like when it
Tilts.
ends with something simple. You know, like to me, this is cool that we can have this times this and it ends up being 1. I think that's cool. It's very nice and neat and tidy.
Still giving me vibes. Something is coming. I can feel it.
Oh, no. All right, next one. Ooh, you're gonna like this one. You're gonna like this one.
Are you sure?
Or you're really not gonna like it. One of those two. There won't be any, oh yeah, no big deal.
Oh, no.
I'm leaving. Surprising thing, I'm not a fan.
Shocker.
Can we cancel sine squareds up there? Why not? Because they're being added and subtracted. We cannot cancel parts of things that are being added and subtracted. So,
Rules
question
schmools.
comes, what are we gonna do? I know, I thought I heard that too.
Yeah, same.
Did you guys hear that?
What?
No, I did not say factor.
You said yesterday.
Mike is different. I didn't say Mikey.
Uh-oh,
Something else.
Mikey said factor? You think Mikey's right?
Why did doubt factor?
Yes.
I swear to God.
Once upon a time, a long, long time ago, back in like September or so. Ain't that right?
They're right, yeah.
I feel that I made a very big deal
About knowing
about
how factor.
factoring. And one of the things that I believe I said was something along the lines of,
You will always
it's
factor.
not going to disappear.
It-
Guess what? It's back.
It was a nice break.
It could always disappear, you know. I could just make it disappear.
Yes, I could just become one of those mathematicians and find
Let
a
me
way
ask you
for
this.
math to not be factored.
Is that, can you factor that?
1 minus n.
The
Maybe.
question wasn't, do you want to factor? The question was, can you factor it?
Probably.
The answer is yes. How would you factor that?
1,
1.
and squared. 1 minus n squared.
Oh, once people started to roll, they finally got it. What is that called, by the way?
Banana.
D.
Difference equation.
Difference of squares.
Different.
See, when people talk, it just spurs things on with everybody. Okay, you got the difference part, and you couldn't get the squares part, but you had said it, and so it clicked to somebody else. That's how we work together, and that's how, as you guys get older and you start getting ready to make lots of money, that's what's going to happen. You're going to work together.
Are we gonna make money though? I don't know.
What don't you know about that? You're not gonna work together or that you're not gonna make lots of money?
Oh my gosh. Okay, wait, I love
He
this.
said, I don't know about that.
You got excited.
Yeah, because look, 1 minus sine x squared.
I will tell you, excuse me, please, hello. Thank you. I will tell you right now that the better that you collaborate as you move on, the better a career you're gonna have. And that's gonna hold true for college, and it's certainly gonna hold true when you get into the workforce, into the real world, okay? Because who's smarter, you or you and 3 other people who are all about the same intelligence?
3 other people.
I said you and 3 other people. Okay? But obviously, isn't it easier to have 4 people working on something than 1 person?
If they're
If they're all the
competent,
same intelligence?
if they're competent, yes.
But I mean, would you rather have you
Got you.
or you and 3 other people who were all just as smart as you were?
Done.
Well, but,
That was actually
and that's
nice.
exactly my point,
That's a good
is
problem.
to be successful, you have to be able to collaborate. And that's one of the things that you want to work on as you continue moving on. Right now, you guys are in high school. You're 14, 15, 16, 17
This is
years
where I write
old,
my
right?
notes.
Is anybody in here 18?
Not yet.
18. Not yet. So,
In
but
November.
if you start thinking about that stuff now, then by the time you really need to be good at it, you will be. And the people that aren't, when you go to college and you're supposed to be working with some people and you get some people who aren't very good at it, well, you'll toss them aside and you'll work with people who are better at working together. And all of a sudden, you'll do better, and then in the real world, it's exponentially so. Anyway, let's continue. So now we get to factor with
It's
trig
not as
functions.
bad as you think.
Is it? You've already done it? Factor with trig functions. So, what does the top look like?
1 plus sine squared x.
1 plus sine squared of x.
1 minus sine squared of
Minus
x.
Sine squared of x.
Over 1 plus sine
Over
squared
1
x.
plus sine squared of x.
And they cancel
Cool.
out.
Is there any good news?
They cancel, and that
Now
changes
we
to
can
cosine
cancel.
squared x.
Yeah, absolutely, because now we're not canceling parts of things that are being added and subtracted, we're canceling the entire thing, and that's fine. So 1 plus sine squared of x and 1 plus sine squared of x can get canceled, which leaves us with 1 minus sine squared of x,
Which is cosine squared x.
which happens to be cosine squared of x, and we're done.
Oh.
And that's kind of cool. Again, we took something, when I wrote this up here, you guys were freaking out. Understood?
Karma's always
I agree with you. But now that you did it, you kind of go, all right, I just gotta not freak out. And if you can avoid freaking out, you'll be able to get through these. Let's see, we'll do this one. All right. Let's, no. Okay. All right, so the first part of your homework tonight is going to be a bunch of problems like that. A bunch of simplify problems. Okay, you got, I don't know, about, I said a bunch. I don't know if it's that many. It's, we're 129. Oh yeah, it's a bunch. It's about 12 of them.
Like 14 or 15.
And then after that, you're going to get a few problems. Excuse me, please. You're going to get a few problems that are going to look like this.
What are we doing?
What is different about this one?
It's not true. It's not true.
Foil?
But then that
I haven't heard what I've I haven't heard the answer to that either.
It's
It's
not.
what? It's an equation. Right? This wasn't an equation, this was an expression that our goal was to
Simplify.
simplify the expression.
Simple.
What's the answer?
That cosine squared x.
The answer's there. We gave you the answer. We said, here it is. This is equal to that. Except what we want to do now is we want to verify this. This is called an identity. It's called an identity because the left-hand side is equal to the right-hand side. It is a fact. This is true. Our job is to verify that it is true. So, there are a couple of things that will pop up, and we'll do a lot more of these tomorrow, but you'll have a couple tonight to kind of introduce you to them. And so there are a couple of rules that hold true when you are verifying identities. The first rule that holds true is because we are trying to verify the identity, we can't use the fact that they're equal to our advantage. And what I mean by that is we can't do anything to both sides. We can't add 2 to both sides or subtract 5 from both sides or multiply both sides by 7 or anything like that. What we have to do is basically work on one side until it becomes the other side. Now, what that really means is that it's pretty much the same as what we've just been doing. We're typically going to take the more complicated side and try to simplify it and hope that if we do that, we get the other side. And so the nice thing is that here we started the problem, we didn't know what the answer was. Here we're starting the problem. We know what the answer is, we just have to make sure that we can get to it. Does that make sense? So it's almost like I looked in the back of the book and saw the answer. Now how do I get from there to there? Absolutely. If you don't know what to do, that's why I give you odds all the time, so that you can look in the back of the book and use that to help you. So, we're going to take the more complicated side and work with it, and hopefully it'll become the simpler side. So when I'm going to do these problems, I'm not even going to pay attention to the simpler side at the beginning. I'm just going to take this and start working with it. So, if I were to take this and start working with it, what would be the first thing you'd do?
Foil.
Foil. Woohoo! Unfactor. Okay, now, wow, we're yapping a lot today. I need my time, okay, please? Thank you. These 2 parentheses are binomials. Can we use a word that starts with a C? C-O-N.
Coefficients.
N, not M.
Connotations, conations. I can't remember.
Conics.
Connections.
C-O-N.
What's the next letter?
If I give you the next letter, that kind of gives it away, I
Watch if
think.
you can get it.
Next letter is a J.
Conjugation.
Conjugates.
Conjugates. See, I told you. it was-
Conjugation.
They're conjugates. Okay. What happens when we multiply conjugates?
We get them.
They don't cancel.
They square.
Right, they don't cancel out. Good.
They squared.
How do we multiply conjugates?
Don't you just take the first term and the last terms?
Why?
Because the middle terms.
In terms of the middle, we'll just
The oi in FOIL, right? You guys said FOIL?
Yeah.
The oi, the outside-inside terms, will cancel. Outside we have plus sign of x, inside we have minus sign of x. So they cancel. So when we have 2 conjugates, it's just first and last. So in this case, that gives us
1 minus sine of x squared,
1 minus
sine squared x,
x.
which equals cosine squared x.
It's kind of like what we did here, reverse. So now, is this as far as we can go with this?
Yep. Because it equals cosine squared x.
Okay, well, we need to go then.
Oh, cosine squared x.
So what is 1 minus sine squared of x?
Cosine squared x.
Cosine squared of x. Is that as far as we can go?
Yes.
Yeah, so now let's check the right side and see what we need to. Equals cosine squared of x. And so we were done. We have taken the left side and turned it into the right side. Now, what is the answer to this problem?
Cosine
Oh,
squared
we have
x.
to find the
True,
domain.
true. Verify.
I don't know.
The answer is the process. Okay, so you know how the last few days I've been saying to you,
Show your work.
show your steps, show your steps, show your steps, show your steps. This is why. Because in this case, in these problems, your answer is
Be there.
the steps. So if you don't show your steps, you haven't done the problem. Because, I mean, I know what the answer is, right? 1 minus sine of x times 1 plus sine of x is equal to cosine squared of x. What's the answer? Well, the answer is the cosine squared of x. I know that. I know that that's what I got to come up with. So to write at the bottom cosine squared of x equals cosine squared of x, well, of course, I know that. How did you get there? That's what I want to see. That's what we have to see. Now, tomorrow in class, we'll do some ones that have a little bit more to them than just a couple steps. Yes, sir? No. No. It's called an identity because the left side and the right side are equal. So, now, there are going to be a couple of problems tomorrow night. Am I making you do that? I'm making you do one of them. And it says determine whether the equation is an identity, a contradiction, which would mean it's not true, or a conditional equation, which means
The three stuff together.
it's true if x equals 2 or something like that. In other words, 3x plus 1 equals 7. That's a conditional equation. Because it's true if
X is 2.
x equals 2. Okay? This is, which would make it an identity. This is an identity because it's always true. That is a contradiction because it's never true. Exactly. Does that make sense? We'll talk more about that tomorrow. But in the question being, will the left side ever not equal the right side? Only if they give us something that says, tell whether it is blah, blah, blah. But all of the other ones that you're going to get tomorrow night, and the couple that you're going to get tonight are going to say, this is an identity, verify that it's an identity.